All right there. Hello, everybody. Good morning, good afternoon, good evening, wherever you are in the world today. My name is Eric D'Andrea. I'm your guest host for today's episode on Quarkus CXF extension. I've got two really smart, sharp, and well-known people here to talk about CXF. So I'll let them go ahead and introduce themselves.
Hi
Go
all,
ahead, Peter. Shumon, sorry.
my name's Shumon Sharif. I am an integration architect at Salesforce currently. I used to work for Red Hat for about 10 years prior to this, and I helped maintain the Quarkus CXF project for a few years before handing over to Peter last year. And prior to that, the original piece of code was developed by a gentleman named Olivier Dufour along with his brother. So yeah, that's me in a nutshell.
Hello, I'm Peter. My primary job at Red Hat is to maintain Camel Quarkus, which is a port of Apache Camel to Quarkus. And traditionally, Red Hat integration, which is a product on top of Camel, also brings Apache CXF to our customers. Our support pushed us very strongly towards supporting CXF on Quarkus, and that's how I came to Quarkus CXF. So that's me. Hello.
Cool. And so just a couple, before we get going here, a couple housekeeping things. I know we got a couple events coming up with some awesome Quarkus talks. I think the first week of July, we've got Dev VCN. Either one of you guys going to be there? Peter, are you going to be there? No? So in Barcelona, there's a bunch of Quarkus talks. The week after, the Riviera Dev, are you going to be there? Either one of you? I know there's a whole bunch of Quarkus talks there as well, the second week of July. I'll be at both of those events. And I know we've got, I think Quarkus 2 or 3.2 CR1 should either be out now or very soon, today or tomorrow or something. So lots of cool stuff cooking. And so with that, I'll bring up your slides here and we can get going. All right.
Thanks, Eric.
Yeah, you're welcome.
So,
all right,
yeah,
take it away.
I think we introduced ourselves already. So, Peter, I'll hand off to you and jump to the next slide.
Thank you very much. So next slide. This sketches the agenda today. First, we will introduce Quarkus CXF in the context of various other technologies which may serve the same purpose. Then we will go on to introducing Quarkus CXF itself. Then we have two short demos, and at the end we will give you some references where you can go if you are interested in writing applications with Quarkus CXF. Next slide. So let's start with how SOAP and web services emerged. Next slide, please. So today we are speaking mostly about SOAP web services. That's the blue bar in the middle. And the question is, how did the landscape look like at the time when SOAP web services emerged? And the answer is there was Corba. I assume nobody knows, or the most of the folks here won't know much about Corba. I have a few points just to give you an idea what the engineers had to work with before SOAP and REST. So Corba was the first RPC standard to bring interoperability across languages and operating systems and even processor architectures. Before Corba, there were only language-specific communications solutions for remote request response style of communication. and there was no good way to communicate across operating systems and even CPU architectures, because you had to take care for things like little and big endian. So Corba was the first to solve this in quite a good way. It came with interface definition language, which could be used to describe the data and operations on it. And the messages were binary. The most usual transport was TCP based, and the protocol was called IIOP. The downsides of Corba and the reasons why SOAP and REST succeeded very quickly later was that the standard was rather bloated, and it mirrored competing interests of the vendors. Like the way the standard was created was like anybody came with a new feature could let it in, and then it was very hard to create a complete implementation. So as a result of that, the implementation were incomplete, and it was very hard to work with different implementations, given that the transport was plain TCP and messages were binary. And that's where SOAP web services come in. The standard was released around 2000, and there were some big and strong vendors like IBM and Microsoft behind it, and that's why it got quite a strong traction. It's interesting to note that REST actually writes its inception year also as 2000, but on the side of REST, it was a dissertation of a guy who set the principles, and there were no big vendors behind him. So the start of REST was somewhat slower than of SOAP. But once REST became better known, it got also more popular because let's switch to the next slide. Because it's a bit easier to work with. If you compare SOAP with REST, and I find this a very good introduction for today, because I assume most of folks here in the audience will know REST and don't know SOAP as good. So this comparison could be seen as a good introduction into SOAP. So where REST is HTTP only, SOAP web services are actually independent of the transport, and the specifications are not forcing anyone to go through HTTP, although HTTP is the most common transport, even with SOAP. But SOAP over SMTP or JMS is possible as well, and it really exists there in the wild. The next important difference is that in REST, or when you are implementing REST, the individual resources are identified by URLs, and the whole concept is based on resources, right? You are accessing resources and performing some basic operations like create, read, or update, or delete on them. But on the SOAP side, it's a bit different. There's only a single URL per service, and the service can implement multiple operations. And the operations are more like Java interfaces. You have an operations, some arguments, and some return value. That's how it works. If you go or if you use SOAP on or through HTTP, then you use only POST and nothing else. On the REST side, the HTTP methods have special meanings, like POST for creating and PUT for updating and GET for reading the resources. On the SOAP side, everything goes through POST, and the operation is encoded inside the message. And given that everything is POST, it's hard to cache, for example, which is much different from HTTP, from the rest. On the serialization side, SOAP is XML only and nothing else is possible there. But on the REST side, you typically use JSON, but XML, YAML, or even protobuf is possible there. Then the definition of the contract. We were discussing this with Shumon yesterday, how to speak about this actually, because VSDL is deeply coined in the DNA of SOAP web services. You can't do anything without VSDL. VSDL is the starting point for everything, for writing clients, and there's one way of writing services that starts with VSDL. But anyway, even if you start with Java annotations, the VSDL is the result, and it's important for every party. VSDL is very strict and detailed. And do we have anything like that on the REST side, actually? And OpenAPI was the only thing we were able to come up with, but OpenAPI is different. OpenAPI is human documentation. Actually, it's much less strict, and I wouldn't say it fulfills all the roles of VSDL. So that's for the comparison of the two. Are there any questions?
I'll interject a little bit. You kind of led off saying something like, most people are familiar with REST and not SOAP, but I find a lot of people get kind of thrown into SOAP because a lot of organizations have SOAP services that have been around, and now they're building REST apps and they need to talk to them. And so now they've got this like integration or cross pollination between REST and SOAP and whatnot. I run into that a lot.
Yeah, definitely. On the previous slide, I have drawn the SOAP bar a little bit fading because it's getting less popular, and I doubt anybody or many folks are writing new services using SOAP. REST is clearly dominant, but as you say, many organizations and maybe some industries have still SOAP services in production, and they are not going to die anytime soon, and that's why Quarkus CXF is important. So that was it from me, and now I'm handing over to Shumon, who will introduce Quarkus CXF in more detail.
Thank you, Peter. So I think it's worth covering at a high level some of the terminologies that we'll be using to describe or cover the Quarkus CXF extension. So the WSDL, which Peter mentioned earlier, is the contract, right, that is used to define the operations, the messages that are going back and forth, and so on. On the right, you'll see an example of the WSDL for a Hello World service, right? So it's platform and protocol and programming language independent. You can literally generate code off of a WSDL in most languages out there. The URL of the given web service is published at a well-known URL or in a registry where you can look up the services that are available to you. And then the last point I just talked about, right? Any provider tools can parse a WSDL and generate code to implement or to access a web service. You'll notice here on the right that the WSDL has, a schema. I'm going to use my mouse to just highlight the areas. Section which contains, the messages going back and forth. You have a hello response, a hello request, the service, and then here the SOAP action that Peter alluded to earlier. But this is what captures a contract at a very high level for a WSDL or a SOAP service. Okay. So SOAP, right? SOAP is an XML-based communication protocol that defines the structure of the messages, so your input and output messages to your web service. The bindings to transport protocols such as HTTP or JMS and so on, and then encoding rules for the data types and a mechanism for error handling. So you can generate SOAP faults from your web services, which will include details on how exactly a failure happened or why it happened. On the right, we have an example of a SOAP request for that same hello service that I just showed you the whistle for, and then a response at the bottom, right? So you can use curl to invoke your web service, hello world web service, and it'll return this specific response.
So there's a couple of questions in the chat, and I don't know if they're too generic or specific, but the first one from Michael, and thank you, Michael, for the question is, and maybe this is outside the scope of the Quarkus CXF, but do you have any resources or examples of how to implement WS Trust with secure context token?
So we have an integration test with SDAs, and I'm not completely sure we cover this use case that Michael mentioned, but at the end, I think at the end of the presentation, we are sharing the URL with the integration tests, and maybe that's a good place to have a look whether this use case is covered there. Because our integration tests are basically small applications that pretty much resemble real applications, and you might start writing your application from there. So maybe the use case is covered there and you can just copy and paste.
Cool.
All right. So the JAX-WS or Java API for XML web services is essentially a framework or an API for the implementation of SOAP-based web services, right? It maps a web service endpoint interface in a WSDL to a Java interface and vice versa. JAX-WS delegates the mapping of Java data types to and from XML definitions to JAX-B, which is a different framework for marshalling and unmarshalling XML to and from Java. And on the right, you see a hello service interface, and this is for the same exact WSDL that we shared earlier. But this is what it looks like. We have, a web method defined for the operation, and then a web service annotation as well for the service itself. And in the demo, I think Peter will go into a lot more detail on how this works and how the data elements get mapped and so on. Okay. So quick overview of Quarkus CXF, right? So Apache CXF is essentially a framework that helps you build web services and includes support for various standards and APIs such as JAX-WS and JAX-RS. The purpose of the Quarkus CXF project is to port the Apache CXF framework to the Quarkus runtime and fully support producing GraalVM native images, right? That's where I think you get a lot of bang for your buck if you're able to work with native images. Apache CXF implements a wide range of standards and specifications, but we're currently focused in the Quarkus CXF extension on supporting only the ones related to SOAP and JAX-WS specifically. So very quickly at a high level, this is what a web service implementation looks like using the Quarkus CXF extension. And Peter will go into the demo with this in a more concrete fashion. But you have a web service defined on the top left. It's an interface that describes your service that you'd like to expose. On the right side, top right, you have the actual implementation of the service, right? This includes the response that you're getting back from your Hello World service. And you can see right here in the Hello Web method how it's constructed and returned. And then in the application properties for the Quarkus application, you can define where exactly the SOAP service gets exposed and the implementer for it, Hello Service Simple, and you can add additional features and so on. These are like a logging feature would enable message logging and header logging and so on in your log files. Okay, back to you, Peter.
Thank you very much. So, Eric, you may want to switch to my screen. And so my task now is to demo creating a simple web service. When you are about to start with a new technology, what do? I guess you either ask ChatGPT, or if the technology is too new for ChatGPT to know it, then you have to Google and you'll probably find the documentation. So here is our documentation, and here is the user guide. And if we want to write a web service, then we just visit the first web service page, and we find out how to do it. But first, we need to create a new project. And the new projects are typically created using code Quarkus.io. And this is very new for Quarkus CXF. I think it's like 3 weeks since we joined Quarkus platform, and since Quarkus CXF extensions are appearing here on code Quarkus.io. And this works only for the newest Quarkus CXF 2.0 version line, and it doesn't work for the older pre-Jakarta 9 1.5 version, where you have to use the bombs manually and you cannot use code Quarkus.io for generating projects. So for the simplest Hello World service, we need just the Quarkus CXF base extension. I have selected it here, and I can download the zip. I'm not going to show you how to unzip. I have already imported this packaged project into my workspace, and it's actually empty. The only interesting thing there is the POM.xml file. It imports 2 bombs. One of those is IO Quarkus platform Quarkus bomb, which manages the core Quarkus artifacts. And the second one is Quarkus CXF bomb, managing Quarkus CXF, a few extensions that are there. First, I'm going to show only the first one, which is enough for implementing a simple service or client. And to start working with Quarkus, how do we code with Quarkus?
I think that's just to kind of throw out there, an interesting point you just kind of glazed over is building a SOAP service or a client, because like I think you said too, not many people are building services these days. More, I would see a lot of interest in the client side of this. Is that what you guys see?
We will have 2 demos. This first is about the service, and the second one will be about clients.
Cool.
Yeah,
okay, so let's.
That is also what we see a lot across various industries. The clients they're still, due to the legacy apps, needing integration work, and then the services are mostly REST. At least that's been my personal experience with new development. Sorry, Peter.
Yes. So I hope the font is readable. It's big enough.
Can you make it just a little bit bigger?
I can try. I made it a little bit bigger. Is it big enough now, or even more bigger?
Try one more.
One more.
Yeah, I think that's good.
Good.
I know it's a pain in the neck because like on your laptop, you're probably at a screen like about this big now, and but it's better for the people watching.
Yes. So the dev mode is failing for some reason now, but it's not that important for now. And we just create the three classes or the three files that Shumon was showing on his slide. So we need a Java package, and we can go back to the documentation, first web service, and we just copy the interface. It's the same one as Shumon has shown. There's just a hello method that will return hello somebody, and there's this web service annotation which comes from the JAX-WS specification, and this is the newest version with Jakarta prefix. The older ones used JavaX. Now, except for the interface, we need an implementation of the interface, and I'll just copy the one from here, paste it here, and as you see, it's not doing anything special, just returning hello text. And the last thing I need to tell Quarkus CXF where this is going to be exposed. And for that, I need these few properties. And it says that the base path for all services will be starting with SOAP, and the hello service will be accessible under SOAP hello path, and its implementation is called like this, and the logging feature will be initially off. So now I have hit save. Quarkus didn't do anything, and I hope I can access the service, the VSDL of the service in the browser. So VSDL, it's there. Although Quarkus is throwing some error still. But anyway, we have the VSDL now, and we could use these Chrome extensions. Chrome extension called, how is it called? It's called Whistler for browsing the contract. It shows that there's only this hello method, and we can create the request. Here you can see the XML source of the request that the hello service would accept. And I can say, what should I say? Quarkus insights. And I just send it to the service, and I got a response with hello Quarkus insights as expected. So this would be it for a simple service, but I also want to show you how the logging works, because when you are developing web services, so web service, then you often need to see what the messages look like that the server is getting and that it is sending back. And that's what this little CXF feature is for. But to be able to use it, I need to add an additional dependency, which is called like this. I'm just going to copy it there.
So that little Chrome extension looks super helpful. I mean, I remember like SOAP UI and the mess that is, like having to like configure stuff and whatnot.
So
seems a lot simpler to use.
So I'm restarting the dev mode in hope that the error is going away. No, it's not. It wasn't there when I was practicing half an hour back.
There's a relationship between when people are watching and how well something works, right?
So let me change this to Quarkus only and send it there, and we should see the request and response here. So it logs this nice message. We can see the HTTP headers, we can see the body, and the body is consisting of the envelope, as Shumon explained on the slide. There are no headers under envelope, there's just body, and the body speaks to hello method, hello operation, and passes the Quarkus parameter there. And this is the response. It's not pretty printed, but it could be configured to be so. And inside the response, we also see some HTTP headers and the payload, which mostly consists of this hello Quarkus return value. And that was it for this hello SOAP service demo part. Over to Shumon.
Thank you, Peter.
Do you need the slides back up here?
Yes.
There you go.
Okay, so next we'll be covering at a high level the SOAP client implementation, right? So Peter just demoed the SOAP server implementation to expose a web service. This is the client implementation where you consume an existing web service. So the first thing you need when you develop a web service client is the service endpoint interface class, right? And all the other model classes it needs. So in the Hello World example, we had the interface of Hello World. So that is the service endpoint interface, and then the model classes that it requires as well. There's several ways to get the model classes. You can write them by hand. You can copy them from a web service project if it's written in Java. You can have a Maven artifact containing the model classes if it's offered by the service provider. One of the most common ways, though, is the last option here, where you generate the model classes from the WSDL using a tool called WSDL to Java. It's provided by CXF, and we've bundled it in the Quarkus CXF extension in a way so that it's very easy and very flexible to integrate. And I think Peter will be demoing that shortly, but you literally just point to your WSDLs and it does the magic for you. So this is the WSDL Java code, or the WSDL Java slide, right? In order to leverage what I just described, you need to have this generate code goal present in your Maven POM XML file. And if you're using Gradle, then you don't need any additional configuration for it. You set this in your application properties, right? This specific property saying where exactly the WSDL files are located. So here we're assuming that the WSDL files are under source main resources /WSDL or source test resources /WSDL, right? And that's all you need to do. The Java model classes will be generated automatically in these two folders. They'll also be picked up by your compiler plugin as sources that are available on the class path. So you can refer to them from your application or your test code. This is what a SOAP client implementation looks like at a high level, right? On the left, we have a REST-based resource, which is calling a SOAP service right here, right? So you're injecting the CXF client. In this case, it's calculator service, my calculator, right? And you can then call operations on this interface, right? And say my calculator.add a comma b. And once you configure your application properties pointing to the WSDL, the client endpoint URL, and the service interface, you can then invoke your web service, your REST service, using this URL, which will then call the web service and return a response back. And this is also all from the documentation that Peter was showing earlier. So it's all very well documented if you want to take a look at that too. Okay.
So there's a question that came in. So why is there a generate goal used instead of Quarkus's goal? I assume Quarkus's goal is what he's referring to.
That's a very good question. May I answer it?
Please go ahead.
So Quarkus is typically operating on compiled classes. And that's why the usual Quarkus build module in Maven and the same in Gradle, that's why it is invoked or scheduled or bound to a phase after compilation, right? Its input are compiled Java classes and the jars of the dependencies. But here we are generating source code, which is before the compilation, and that's why it has to be a separate Maven goal in Maven, and that's why it has to be bound to a phase of Maven lifecycle that is before compilation. I hope I have answered the question.
Yeah, Christoph can post another follow-up if that didn't answer the question. I guess he was talking about Quarkus's build items, specifically. Why using a Maven goal instead of a Quarkus build items?
Well, all those build items are executed after compilation. And that's why this code generation cannot be implemented as a part of it. It's too late.
Okay.
Good. Now, could you switch to my screen again, please? Yes. So I was able to fix my demo. The stack traces are not there anymore. And do you know why it happened? Because I was running from a folder when I was practicing before starting this session. So what you have seen was a stale code, but it still worked, right? Which is great. So now I'm running Quarkus dev mode in the real workspace that I'm showing here in Eclipse, and we now want to implement a simple client. So I won't start with generating Java classes from WSDL. I will start with an easier use case where I will be speaking to the service that I have in the same application, which is trivial. But anyway, it's useful to show some context, some concepts. So let me create a new class in a new package. And as Shumon mentioned, I can inject the client using this Quarkus CXF specific annotation. And I can use the interface as a type, which is hello service in this case. I can call
Peter,
it
could you do constructor injection rather than field injection? Would that work?
That's a good question. I think I don't know. I have never tried it. If this was a standard inject, then it would work because that would be plain CDI.
Yep.
But I'm not sure if this would work for a constructor. Sorry. You have to try. So now I want to invoke the client somehow. And because I don't want to implement a REST endpoint like Shumon shown on the slide, I will just use a scheduled task from Quarkus Quartz, for which I first have to add the dependency. And then I can add the method every 2 seconds. I need to refresh this so that it sees the new dependency. And I can invoke it. Client hello from client. So I have hit save, but because we are not accessing the application from outside, Quarkus dev mode doesn't know that it should recompile the application. So I just hit H to see help, and I see that there is S shortcut for forcing restart, and I'm hitting S now, and it tells me that there's something wrong. Hello service cannot find symbol. I think I missed configuration for application properties, and I may want to copy them from the documentation. Here it is. Copy. So this is my hello client. And as we have seen, it's running on localhost HTTP. Better copy it from the browser. Here, hello. Like this, and the same here. And the name of the class is like this. That's the interface. Let's see if it's going to work. And I have to use the name that I used here for the client, also here, like this. And if I recompile, it still complains. Maybe I need to recompile because I've added the dependency, and Quarkus dev mode couldn't keep up.
It needed to generate the sources probably and reassociate the sources.
So as you can see, the client works. We see hello from client in the console. So that was the simplest client. And now, if we want to demo a more real-world scenario, when I got a WSDL file from a real service and I need to implement my client based on that contract, I would have to do it as follows. So let me go back to the documentation again. Let me visit generate Java from WSDL. Maybe I will mute this for a while. Generate Java from WSDL. So what I need is to make sure that this generate code goal is present in my POM.XML, which it is here by default. Code Quarkus.io has generated it. Then I need to get the WSDL, and we actually need some external service, and I will use a calculator service, which I will just start within a Docker container. So I'm starting this one on port 8082. Let me check if it's there. 8082. This is its WSDL. Again, I could browse its operations, but what I want to do now is to store the WSDL locally so that it's visible for Quarkus code generation mojo before the compilation happens. So it should now be here. Then I need the property that tells the code generator where to look for the where to look for the WSDLs. I'll just copy it here. And it's not under WSDL folder, but it's directly under source main resources. Hopefully it's going to work like this. And now when I recompile, I should see some classes there. Let me show you the log output. It was showing the code generation there somewhere. Can we see it? Where is it? Here somewhere. Invoking, generate tests. No, codex Quarkus. I've seen it. Now it's lost. I'm not gonna look for it there. Believe me. So we should now see some classes generated here. If I refresh, yes, these are the model classes of the calculator service. This is the service interface, which I can use in my client. I'll just exchange this, oops, for the other one. And I need to copy the properties from the documentation here. This is exactly what we are doing now. We started the container on 8082. So I hope this is going to work. So this is our second client. We can delete the previous one because we are not using it anymore. And we need to change the name here for the microcalculator. And the method is not hello anymore, but let's use at 2 and 3. Now let's restart the demo and see whether it's going to work.
You still have the scheduled annotation comment to that, Peter.
Ah.
Yeah, I was just gonna chime in and say the same thing.
It's now active. Let me recompile and see whether it's going to work. No, it doesn't. Let's try to restart the demo. What's the problem? Task job calculator. I probably did something wrong. So localhost 8080 is running. Calculator service is there. I don't know. It warns about something, so it doesn't work for some reason. I think I'm not going to investigate what's the problem. That's it.
You need to get back to the slides. Is that?
Yep.
All right.
So we'll recap a little bit about everything we've seen today and give you some pointers as to where you can get some more information on the Quarkus CXF extension. We have a very extensive user guide, thanks to Peter, and a lot of work that was put in recent months. And it's available at this link here at the bottom. One thing to keep in mind is that the drop down at the top right corner that says dev is pointing at the Quarkus 3 extension and Quarkus 3 compatible extension for Quarkus CXF. And if you click on that drop down, you can switch to other versions in case you haven't had the opportunity to upgrade to Quarkus 3 yet. So Quarkus 2 uses a totally different set of compatible versions of the extension, and it is strongly recommended. It's documented as well. Once you switch from dev to the older versions, it's strongly recommended to try and use a Quarkus CXF BOM or bill of materials dependency, and that should help you pull in the correct versions of transitive dependencies that you need for your project.
Yeah, but there's like if you talk about like Quarkus 2 to Quarkus 3, it's not like a really big deal other than that Jakarta namespace change. If you're just building a simple CXF service or consuming one, there's not a whole lot of difference there, right?
Yep. I agree. Peter, anything you want to share there? I think.
No, I was trying to fix my demo, but I wasn't able to. So
there's a question about support. How long do you plan on continuing to make changes to the Quarkus 2 branch or version?
We have a product on top of it. So the 1.5 branch of Quarkus CXF is going to live for, and now I don't know how long, but it's going to live for some time.
And we have you on recording saying that.
Okay, so here we cover, there's a reference page on the GitHub IO documentation as well, where you can see all the standards we cover, right? I think someone had asked about WS Trust earlier. That's one that's stable and fully supported. And, you can take a look at these standards. These are all provided by CXF and we support them. Everything that's marked as experimental here has been around for a while. It's just that we don't have test cases that are complete. So that's why, we've marked them as experimental. But
is that a hint for future contribution?
Absolutely. Contributions are always welcome. But yeah.
So the metrics one, is that using like Prometheus and whatnot? Like what's the underpinnings of that?
The metrics one?
Yeah.
Yeah, it uses CXF has a metrics provider, and we're leveraging that. I forget the exact details right now, but I believe it's not just Prometheus. You can integrate that with other frameworks too. Yeah.
I guess Micrometer was what I was thinking, not Prometheus. Or is it
right. Format? Yep. Micrometer is the one. Yes.
Cool.
Okay. So we have a lot of examples in the integration test folder for the Quarkus CXF code base, right? You can take a look at this link. These mostly use Docker containers. So make sure you have Docker installed before you try and run these tests. But a huge number of examples and, various scenarios are covered in here. Yep. So these are some statistics for our Maven Central downloads, right? We've had about 200,000, a little over 200,000 downloads in April 2023. The reason it goes down in May is because they haven't compiled the statistics for those yet from Maven Central. But yeah, it's a very large number of downloads, and we're very glad to see the usage and community support and contributions to the project. And finally, hopefully you're ready to use Quarkus, and this demo was helpful. This presentation was helpful. Some links here, right? Peter had earlier shared how to go to code.quarkus.io to initiate or initialize your project. We have the GitHub link to the Quarkus CXF extension, the documentation as well. And as mentioned previously, contributions, pull requests are always welcome. And if you have any concerns with feature or an issue, any issues you'd like to report, please, hop onto GitHub and open an issue or start a discussion. Peter, anything you want to add?
No, I'm fine. Thanks.
Okay. Yeah, I think that's all we had, unless there's any other questions.
Yeah, last chance for those to ask the experts or try and stump the experts. No, I don't think so. So this was super helpful. I know, like from my own personal experience, we get questions, tons of questions, like how do I interact? We've got these SOAP services that have been sitting around forever. How do we interact with it? Is there a Quarkus way to do it? And I think this is definitely the answer. And I think it's something that's been needed for a long time. So myself personally, I'm glad to see this.
Yeah, this used to be one of the most requested features. I think at some point in time. So yeah, I'm glad it's supported as well. The SOAP integration is big.
Cool. All right. I think there's no questions. So, with that, thank you, both of you, Peter and Shumon, for coming. And, thank you to everybody who took the time out of their day to watch, or who will take the time out of their day in the future to watch this episode. So we'll see you again next time. Thank you very much, everybody.
Thanks. Have a nice
Bye.
day. Bye.